In order for you to start making games with Phaser, you will need to have installed a web browser. I'll be using Google Chrome, a code editor, and a web server. Now, when it comes to the code editor, there are many free options out there. There are many good alternatives, and it doesn't matter which one you choose. You can use whichever code editor you are already familiar with. Now, when it comes to the web browser, I want to show you two ways of installing one, and also I want to explain why we need one. Well, let's start with the beginning here. What is a web browser? A web browser is simply a program that will receive requests from the browser, and it will serve files as a response. It will send our game as a response. Now, why do we need one in the first place? Well, let me show you. We've got a Phaser game here. And what I'm going to do is what you normally do with websites that are in your computer. You just double click on index.html and that opens it on the web browser. So let's do that and see what happens. Wow, that's not what we anticipated, right? That doesn't really look like a game. Just to give you an idea, this is what the game should be looking like. Something like this. But we're not seeing any image in here. Let's go and open the developer tools to see if we are getting any errors. So, as you can see, we are getting a bunch of errors here in the developer tools. They say that the files were failed to be loaded. And the files that the browser didn't load are all of these image files. So we had a background, a player, a dragon, and other things. And what else do we get here? It says that cross-origin requests are only supported for certain protocols. That includes HTTP and HTTPS. So the way that we are loading these files, when we double-click, it uses the file protocol. And for security reason, the browser doesn't allow you to load files in this way from the file protocol. Now, you can say, oh, that's very annoying. I don't like that. Well, the reason why that is in place is because if that wasn't around, imagine you go to a website and any random website could have access to the files in your computer. The web would be a very dangerous place if that was the case. That is why browsers protect our files in this manner. That means that we cannot simply go and double click on a Phaser game. We need to load it through a web server. The simplest way to get a web server running that doesn't require any advanced technical knowledge is to install the Brackets code editor. So this is a free open source code editor which comes with a web browser inbuilt. So let me show you how that works. I'm going to open Brackets. And when you open Brackets the first time, or any time that you want to start working, the first thing you need to do is go to File and open the folder. Find the folder that you want to serve with the web server. So I'm going to find the folder where my game is located. I already had it here. So I'm going to select that folder. And that will show me all of the files here. So I should be seeing index.html and whatever other files were in my game. And then what you do is you press this live preview button. So when you press that, Brackets opens a Chrome page and it serves your files using a web server. So you can see that we have a specific URL here, that this is the URL of this web server. So you could copy this and you could go to a different browser. You could open Firefox, for example, and open this and you will get the same game as well. And now what you normally want when you are developing the game in this way, and that is also with a normal Chrome or any browser, you want to have the developer tools open because you want to be aware of any errors or any issues that there could be. In this case, this was expecting to have an icon file for the website, so it's not related to our game. And what's really cool about Brackets is that it comes with this auto refreshing thing. So if I go and change anything in my game, so don't worry about the code in the game. We haven't looked at Phaser yet. I'm just showing you how things can be changed. So I'm going to quickly change the location of our player. So let's see if I place my player in a different location and I save, and the player has been moved to another location. Now, if at one point in time you don't want to have this refreshing behavior, all you do is you simply click on that same live preview button, and then the game is still being served from the web server, but if you change things in the file and you save the files, this is no longer refreshed. So that is how you can serve files using brackets. Now, a more advanced way of doing the same thing is by using a tool called HTTP server. So the first step here would be to install Node.js. Node.js is a runtime that an application that allows you to run JavaScript code basically on a server, in this case in your computer. So you would need to download Node.js. This works in all platforms, by the way. It's not related to Windows, and same thing with brackets. So I always prefer to download the LTS version, which stands for long-term support. It means that version is going to be maintained for longer. So what you do is you download and install Node.js. Then if you are on a Mac, you can go and open a terminal right away. If you are on Windows, I wouldn't advise using the terminal that comes with Windows. I prefer to download a terminal that works more like a Unix system. And for that, you can use the Git Bash terminal. So you can download Git Bash for free. And once you've downloaded and installed that, you'll get access to this nice terminal. So regardless of whether you are on a Mac or on Windows, the step that comes next is to install this HTTP tool that I was mentioning. So what you do once you open your terminal, first you need to, if you just type npm, you need to make sure that that is installed. So if you get something like this, it means that it is installed. It is recognizing it as a command, and that would have happened if you installed Node.js correctly, basically by following the default options here. So I have npm installed. So now what I'm going to do is type npm install http-server. This is the name of the package we want to install. And then I'm going to type -g, which means this means install this package everywhere in my system so I can use it in any folder. So if I press enter, that's going to install HTTP server. I already have it installed, so I'm not going to press enter this time. And now that we have that installed, we need to navigate and find our folder where the game is located. So if we go here, the game in my case is located in the D drive, www folder, Phaser3 folder, Crossy RPG. That's where my game is located, but obviously it will be different in your case. So what you have to do now is navigate to that folder, and that's why I said that this option requires some basic command line knowledge. If you're not familiar, if you're not able to navigate to a different folder, then you should be using the brackets alternative. So in this case, I want to go to the D drive. So I'm going to type cd d : that brings me to the D drive, and then cd www, and if I press tab, it kind of auto completes. So I can start typing Phaser and auto complete that, but in this case, I've got two Phaser folders. I'm going to type Phaser3, and then I'm going to type Crossy RPG, and that's it. So now I'm inside that folder, and now that I'm inside that folder, I can type http-server, and that should launch our web server for that particular folder. So I'm going to press enter, and I'm seeing now that the server is available on these different URLs. So I'm going to go and copy one of these URLs and go back to Google Chrome and type that URL here, and voila, we get the game now working as it should. And so when you are developing, you will want to keep your code editor open and your browser open. And as I said before, I like keeping the developer tools open. In this case, I've opened them and they are on a different window. If I want them on the same window, you can go here and just place them in the area where it's most useful to you. All right, so the challenge here for you is to follow along and make sure that you have everything set up on your end, that you have that web browser running, that you are able to run a simple Phaser game. And once you've completed that, I will see you on the next lesson. In this lesson, you will be having that first hello world moment when we will create a new Phaser game. It will be an empty game on an empty scene, and you'll learn what a scene is as well. But it is always exciting when you get that first indication that you are in the right direction. All right, so find the files download the files of the course and make sure to find the folder named 00-starting. So these are the starting files of this project. So you can start at the same time that I am starting. Everything from here you will have to build along as we make progress through the lessons. And of course, the complete solutions basically are provided as well. Okay, so in here you'll find very few things. You'll find index.html file. You'll find an empty folder named JS, which is where our JavaScript files will go. And you have a folder named assets, which contains the images of this project. So let's have a look at what's inside of index.html. I'm going to open that in my code editor of choice. I'm using Atom here. And you can see it's a really simple file that doesn't really have anything. We want to start by including the Phaser library. So let's go and find the Phaser library. Let's go to phaser.io, the homepage of Phaser, and there will be a link that says download, so you can find it up here or on the side. And then in this case, this link here will take me to the latest version. What you want is the latest 3.x version. You will most likely not be on 3.3, you'll be in another version, but all of the 3.x versions are supported in this course, and all of the examples will run like a charm. And if there was anything that's for some reason stopped working, we will be adding nodes to support that as well. Okay, so there are different ways of including this library. You can download the JavaScript files directly from here. You can also, if you're familiar with GitHub and with Git, you can clone the repositories. You can choose to do that. And if you are an NPM user, you can also install it in that way. And lastly, you can include the CDN in your HTML. So you can copy and paste this in your HTML file and it will work. The option that I prefer is just downloading the JavaScript file, and you can either download the big version, which is human readable. It has comments, it has indentation, and that is what I like using for development, because then I can easily go to the source code of Phaser and understand how things work straight from the source, which I would strongly recommend, by the way. If you are on production, if you want to put your game in the internet, you always going to go with the minified version, which strips out all of the comments and it is a smaller file. So I'm going to click here, save as, and I'm going to save that file in my JavaScript folder. So I've downloaded phaser.js into my starting folder JS, and now what I'm going to do is make sure to include it here at the end of your body. So this will be js/phaser.js. That is the location of my file, which is here. I'm going to now create another file here, which will be game.js, and that is where our game code will go. Make sure to also include that file after the Phaser file, because that file will make use of the Phaser library. So inside of game.js, there are three things that need to happen. I need to create a new scene. I need to set the configuration of the game, and then I don't want that to be capitalized. And then I actually need to create a new game and pass the configuration to it. Now, first things first, what is a scene? Think of a scene as the place where all the action takes place. That is where you'll be adding your game characters, your enemies, everything in the game will go in a scene. In Phaser, you can actually have multiple scenes, and you can use scenes to represent, for example, different screens, or in some cases, different levels. You can even have multiple scenes open at once. You can pass data between them. But for the purpose of this game, we are going to be using a single scene. So I'm going to go and declare a new variable, which will be called game scene. And this will be a new phaser.scene object. We need to pass in a name for this scene, which will be game. we are creating this new phaser.scene object, and that is provided by us by the phaser library. Now I need to create this configuration object. So I'm going to call this config, and this is simply a JavaScript object. We need to pass a few things here. First, we need to pass how will Phaser render this game on the browser? Will it use WebGL or will it use the Canvas API? Well, we're going to let Phaser decide by typing phaser.auto. That means that Phaser will use WebGL if available, and if not, it will use Canvas, the Canvas API. We also need to pass the size of our game, 640 by 360, and we need to pass the scene or the list of scenes, in this case the single scene. So we are just going to pass that scene that we created. That is our configuration object. It's just a JavaScript object. Now let's go and create our game. Let game equals new phaser.game. So we are creating another object here of type game, and we are going to pass to this game the configuration object that we have previously defined. Now, if you go and open this in the web browser, and remember that you should be using a web server. In this case, I'm already using one. I've already set it up. It's not going to matter right now because we're not loading images. But once we start loading images, you will really need the web server running. So let's see what happens. And as you can see, we get a black screen here of the size that we defined. And obviously there's nothing there because we haven't added anything. And down here, we get an indication that Phaser is working. And it is in fact using WebGL because WebGL is supported by this browser. Cool, so that is good. If you have reached this point, it means that you can move on to the next lesson when we will be adding images on the screen. So that is when things start to get really interesting. But before we head off, there's just one thing that I want to do here, which is to use CSS to make my life a little bit easier here, because I want to have both the code and the web browser visible at the same time, but our game is a bit bigger. So if we go and inspect this object, you will see that it's simply a canvas element. So if we add some CSS here, that might make our life a little bit easier, or it will make my life as a presenter easier. But I think for you as well, when I'm making games with Phaser, I also like to always keep both visible, although I also use a different screen, second screen. But still, it's a good use of your space. So we're going to select canvas, and we are actually going to give it a width of 100%, so that the canvas scales to the size of our browser. All right, so after that, we are all good now, and I will see you on the next lesson. In this lesson, you'll learn to create sprites in Phaser. This means basically displaying images on the screen. The first step, of course, to creating games. The images that we'll be using are all under assets. So we have our background image, we have a dragon, a player, and a treasure. So we'll start loading the background. And the loading will occur inside of our scene. Scenes in Phaser have different methods that have a different purpose for the life cycle of that scene. This is a concept that we will be looking at again and again in this course. So let me bring up a diagram of this life cycle for the first time for you to see. When a new scene is started, there is a method called init, which is called once, and this is used to initiate certain parameters of your scene. It is not always used. After that method is called, we call a method called preload, and this is where the asset preloading takes place. Now, what does that mean? It basically means that Phaser will load all the images and all the audio files and other external files that you might want to use in your game. All of those files will be loaded to memory so that then they can be used without any delay. When you want to show an enemy or a character, you don't want the player to have to wait until that image is loaded. Imagine if you played a video game and the enemy is not loaded yet, so you see a pink rectangle, and then a few seconds later you see the actual enemy. That wouldn't be acceptable for a game. So that is why we need to load all the images first, and then in the create method, which is called only once after the preloading phase finishes, this is where you actually create your sprites and display them on the screen. The update method, we will look at that later in the course, but it is basically called on each frame during the gameplay. So it is used for things that need to be checked at all times. All right, so let's go and create this preload method for our scene. So what we'll do here is we're going to load assets. So we're going to type gamescene.preload, and this will be a function. Oops. This will be a function, and it is inside the function where we are going to be adding all the code. So let's start by loading our background. And for that, we are going to type this, which refers to the scene object. Our scene object has a component called loader, which gives us access to this load object here. So we're going to load image. That is the name of the method that we use to load an image. And we need to give the image, we need to give it a label. It can be anything we want. It doesn't have to be the same as the name of the file. So I'm calling it background, but again, the image is called background.png, but this could be anything. This could be XYZ. And now we need to specify the location of our image. And in here, we will type assets/background.png. So in here, you need to enter the correct path and name. This is just for labeling purposes. Close that with a semicolon. All right, so we are loading a single image here. We can go and load more if we want. So I'm going to copy and paste this line, and we're going to load the player as well. I'm going to call that player, and the file is called player. Okay, so that is our preload method. Nothing is really happening until then. We actually want to create the sprite now and show that on the screen for the players to see. So this is called once after the preload ends, and this will be our create method. Remember that we had preload and then create. We're not using init just yet. It's an optional method. They're all optional, to be strictly speaking, but we need to preload images if we want to then show them on the screen. So this is also going to be a function, and in here we are going to create a sprite. Create background sprite. Again, we are going to type this. This refers to our scene object, and this.add.create allows us to this.add.sprite allows us to create a sprite. Now, where do we position the sprite? We need to understand how the coordinate system works. So I'm just going to type 0, 0 first, and you will see the result. The image that we are loading, I need to specify that label that I defined. So whatever I entered here is what I have to enter in here, regardless of the name of the file. Okay, so let's see if this shows anything on the screen. Let's see if we made any mistakes. Well, we're not seeing anything, so let me just make sure that we are in the right folder here in the web server. Okay, here we go. So as you can see, we are displaying the image, but it's not looking quite right. We need to understand how the coordinate system works first. In phaser games, we have a two-dimensional coordinate system. So let me go and draw this coordinate system. Basically, we have an x-axis that goes from left to right, and we have a y-axis that goes from top to bottom. So what does this mean? It means that the origin is actually on the top left corner of the game. So if we bring our game here, the origin, the coordinate 0, 0 is in this point here in the corner. And if you go in this direction, this will be 0, 0, the origin. If you go in this direction, you are going positive on x, and if you're going down, you're going positive on y. So this is different to how we learned in school, where we learned that it was like that. Well, it works differently in the context of working with the canvas in general and phaser. So now, what about the position of a sprite? Let's say that we have, let's say that this is 0.5, 4 or something like that. And we want to place our player here. So if we say that our player will be in position 5, 4, that point there, what we are saying is that the center of our sprite will go in that position. So if this is our sprite, let's say that this is our player, the center of the sprite will go in the position that we give it. If we go back to our code and to the result that we obtained, we will see that we told phaser to place the background position 0, 0. So what it did, it took the center of the sprite and placed that point on 0, 0. The point that you specify is called the origin. So by default, the origin of a sprite is the middle point on x and the middle point on y. Now, that can be a bit complicated now, right? Because I actually want this corner here to go on the top left corner. So there are different ways on how you can achieve that. The first one is to actually change the origin of the sprite so that the new origin is the top left corner of the sprite. So let's go and do that. We are going to first place this in a variable. Let's call this background bg. And now we're going to change the origin to the top left corner. So bg.setOrigin is a method that is available for us to use on sprites, and we can specify the coordinates inside of the background that will correspond to the origin point. So if you look at the background, the coordinate 0, 0 is the top left. So what we are doing here is that we're saying the top left of the background is the new origin. So that when you place it in a certain position, it is now this point here that will be placed on that position. So let's save and see what we obtained. Awesome. So we've got that showing now where we want it to be. So that is one way of doing it. It is just changing the origin. Another way of doing it, if you keep the origin where it was before, would be to basically push the position so that the middle actually goes in the middle of the screen here. And that brings me to the challenge of this lesson. So place the background sprite in the middle of the screen by changing its position. So don't change the origin like we saw. Instead, use a method called setPosition, and you can go to the documentation and find this method, or you can have a try and see if you can do it without the documentation. But in any case, have a go, have a try. If you're not sure how to do it, that's fine. I will show you now the solution. All right, you had a try. Now welcome back. Let me show you how we can solve this challenge. So let's go back to our code. And let's get that game showing again. So what I'm going to do here is place a sprite in the center of the screen using setPosition. So I'm going to type bj.setPosition. And the first parameter here will correspond to x, and the second parameter here will correspond to y. So I know that the screen is 340 wide, so I'm going to type in 340 divided by 2. I can also type 320, but I just want to make it very explicit so that you know where these numbers came from. All right, so this is the solution, or it is a solution. And if you refresh the page, you will see that the sprite is perfectly positioned in the middle. So that is one way of doing that. Now, I'm sure that some people will wonder, okay, how can I just grab the width without having to manually type the number? And yes, that is possible as well. So if you want to grab the width of the screen, let's call this game W. If you want to grab that value, you can actually do it by typing this, which refers to our scene.sys, which is the system component. It gives you access to game level properties. Then game, that gives you access to the actual game object. And then there's a config object. And guess what? This config object will give us access to all of these things. So in here, we can type width. And we can do the same thing with height. So I'm going to call this W game W and game H, console.log. Let's show both of them and see what we get in here. So I'm going to refresh that and you can see the numbers here. Now, there's a couple other things that I want to show you right before you head off to the next lesson. The first one is that you will want to know what properties are available for us to use in different sprites. So something you can do on your own or while you're developing that's quite helpful is to simply show these sprites, show a sprite on the console. And you will be able to, you will learn quite a bit by doing this. So you will see the object sprite here, and you will see all of these properties like the alpha value, and you'll see that there's a animations object here. There are a lot of properties, and it is useful to, over time, get more and more familiar with what's available for us to use. So for example, that same position method, I'm sure we can find it here. So if it's not right here, it will be on the prototype, which is the object that this object comes from in simple terms. So we can find this set position method here. The other methods that we'll use for sprites, they're all going to be found in there. And you can do the same thing with the scene as well. So if you type console.log and this, you are putting your scene, your game scene, into the console, and that will also give you so much information and so much detail of what is happening here. So for instance, that add that we used when we were preloading, it's here as well, and the load is there as well. The load is the one that we used when preloading. So that is something that I just wanted to mention because it's quite useful in general to do. All right, so to summarize here, we've done quite a bit. We started by talking about the life cycle of a scene, or at least part of it, because there are more methods than those that I showed you, but these are the main ones that we'll be using. And we created our preload method where we loaded all of the image assets. We gave each image a label. And then we went on and created our first sprite, which was the background. And we talked about the coordinate system, the positioning, and the origin. All right, so that is all for this video. I will see you on the next lesson. We are now familiar with how to position sprites on the screen. And what we'll do in this lesson is learn how to increase or reduce the size of our sprites. That is called scaling. We'll learn how to scale our sprites. And we're also going to look at a few other sprite related things. We'll learn how to flip sprites, and also what the depth of the sprite does when you render multiple sprites. So I'm going to start by adding a second sprite here, which will be the player. And we're going to call that variable player. And we'll create this variable in the same way as we did before. So we'll give it a position. I'm going to place it somewhere, let's say 50 pixels, and I'm going to place it halfway on Y. And the label of our player is player, so I'm going to grab that and paste it here. If I go and refresh the page, we will see our player on the screen. Now, as you can see, the player is showing on top of the background, and that is because sprites are shown in order, in the order in which they are added. So we have added the background first, and then we are showing the sprite of the player on top of the background. But what if we cut this and paste it here? What is going to happen then is you are not going to be seeing the player because the player is underneath the background. But there is something interesting here that we can do. So I'm gonna show the player in the console to show you the depth properties. Let's do the same thing with the background as well. Let's add those two console entries and refresh the page. So now we can zoom in here and expand on these objects. So you'll see that they have a property called depth, which by default has a value of 0. So that is for the player, and we'll see the same thing for the background. And yes, by default, sprites will be displayed in the order in which they are placed in here. However, you can change that by changing the depth of the sprites. The higher the number, the more on top that the sprite will be. So we saw that both had a depth of 0. So if we give our player a depth of 1, you will see now that the player shows now on top, even though it is created before the background. So that is what the depth property does, and that can be useful in situations when you have multiple sprites and you want to have control over what goes on top. All right, so that is the use of the depth property, but for the purpose of this game, I'm actually going to roll that back and go back to where we were before. Okay, so we have our player now in its original position, and there was one other thing that I wanted to mention, which in the previous lesson we modified the position of the player by using set position, right? But you can also modify X and Y directly in this way. So you can go and change, for example, the X value of the sprite, which will push it to the left in this case. And you can do the same thing with Y. And in fact, that is how I normally position my sprites or when I need to change the position. But the set position method is also, it's there for you to use if that's what you want to do. All right, so now let's go and talk about the actual topic of the lesson, which is to scale sprites. How would we go about increasing the size of a sprite? Well, there are different ways of doing it. So first, we've got the set scale method, which works in a similar way to set origin. This means we have a value for X and a value for Y. Now, what is scaling exactly? Let's have a look at that first. If you have a sprite that has a certain size, let's say that my sprite is 3 by 2, so the width is 3 and the height is 2. Scaling is really multiplying both the width and the height by a number. So if you scale your number, if you scale your sprite by 1 on both X and Y, you're really multiplying this by 1. So you're not changing the size. But on the other hand, if you want to double the size, you would multiply those two numbers by 2. And then you'll have something that is twice as big. So if you multiply that by 2, that will give you 6, and this will give you 4. So the resulting sprite will be displayed twice the size as the original sprite. Now that is a very nice rectangle. Okay. Now, what if you want to reduce the size of your sprite? So you want your sprite to be half the size. Well, if you want it to be half the size, you would multiply both numbers by 0.5. So if you scale by 0.5, you will get 1.5 here, and 2 times 0.5, that will give you 1. So you'll get a sprite that is half the size. So this will be 1, and this will be 1.5. So that is really what we're doing with scaling. We are multiplying the dimensions of the sprite, what I call the display dimensions here, by a certain number. And you can scale a sprite by a different number on both X and Y. So you don't have to use the same numbers. Now let's go to our code and see this in action. So I'm going to start by just setting it to 1 to show you that it's not going to change the size of the sprite. But now we can set this to 2, and we'll have a sprite that is twice the size. Moreover, if you set the same value for if you just enter one number, that number will multiply both X and Y. So that just saves you a little bit of time. If let's say we want to make our sprite, let's move it a little bit more to the right first. Let's say I want to make my sprite half the width, but twice the size in terms of the height. Then I'm gonna get a distort sprite like this. And let's have a look at some properties here when we show this on the console. So I want to show you the width and the height, and also the display width and display height, which are properties of sprites, of all sprite objects. So let's expand this and have a look at the properties of the sprite. Now, the width of the sprite. Now, what's the original width of the sprite? That is something that we should look at as well. So let's find the file and just check the size. So this is our player. I'm going to go to properties here and details, and that's going to show me that the size of this sprite is 64 by 72 pixels. So that is the size of my sprite. And you can see here that the width is showing as 64, and the height, where is it here, is showing as 72. So even though we've changed the scale of our sprite, those properties, the width and the height, don't change. What does change is the display height, which now is twice the size. So it's 2 times 72, it's 144, and the display width should be half the size. So the full width was 64 and the display width was 32. Another way of scaling a sprite, so let's leave this one. Let's leave this one as it is here, and let's write some comments so that you know what this meant after you look at this code in a few days or whenever you get back to it. So we're going to say that we are reducing the width by 50%, and we are doubling the height of the sprite. So let's now load another image and use some other manner of changing the scale. So I'm going to load, I think it was called dragon. Well, we're going to call it enemy, but the file is called dragon. So I'm going to go here and create a sprite. Let's create an enemy. So let enemy equals this.add.sprite. Let's position this a bit further from the other one, but at a similar Y position. And enemy dot, we can change the properties to X, Y directly, like so. Scale X, let's make it double. Enemy dot scale Y, let's make that double as well. And reload the page. So we made the dragon twice the size. If we go and change the scale X, for example, you'll see that that is the original width, and we are making it double the size. So that is another way of scaling. It is exactly the same behind the scenes. So all this method does, it changes these properties. So that is if you want to change properties directly. And you can also go and change the display. That if you did want to set a specific size for the sprite, you could change display width and display height. So let's add another enemy and do that with that enemy. So let's go and create a second enemy, and then we're going to call this enemy 1. I guess this one should be enemy 1 and the other one should be enemy 2. All right, and let's place this a little bit further. So we got now 3 dragons there, 3 sprites. So let's say that you want the width of this enemy. So we're gonna go display width. You want the display width to be 100 pixels, then you just change it in that way and it will display, it will now be 100 pixels. Let's make it a little bit bigger, like 300 pixels, so that it's more clear. There you go. So those are 3 different ways in which you can change the size of a sprite. And now the last thing that I wanted to show you was how to flip a sprite. Let's say that you want this dragon here, you want this dragon to be looking this way, to be looking where our character is. So that means we need to flip it on X. So let's go and do that. That is enemy1. And then what we do is just set enemy1.flip x, like so, equals true. And if we refresh the game, you'll see that it's now looking this way. You could also flip it upside down if you do enemy1.flip y equals true. So you can play with those options and combine all of these things. So we are combining scaling, we're combining flipping, you know how to position a sprite, and that covers almost all of the basic things you can do with Sprite in terms of basic positioning and rendering of sprites. There is one more operation that we need to cover, which we'll look into in the next lesson, which is rotation. So practice what we've done so far, position a few sprites in the game, and make sure that you get comfortable with the scaling aspects, with how to increase the size of a sprite, how to reduce the size of a sprite. And what's important to mention is that the origin of the sprite is always in the same position. So all of these changes that we are making in our sprites, the origin of that sprite always stays in the same position in the game. In this lesson, we are going to cover the rotation of sprites, and we are also going to look at the update method, which is a method such as create and preload. It's part of the scene's lifecycle, and it is a method that we can use to change the property of something over time. So let's start with the rotation aspect. There are different ways of rotating a sprite. But the first thing that I want to mention is that the rotation always takes place about its origin. So the position of the origin doesn't change. So let's go and let me refresh this game here. Let's go and increase the size of our enemy a little bit, just so that then we can look at the rotation in an easier way. So let's set the scale to 3, and now we're gonna rotate it. Now the way that you rotate it, you can either use angles or radians, whichever you are the most comfortable with. And when you enter a positive value of rotation, that is as if think of your left hand. If you were rotating something with your left hand, it is basically clockwise. So a positive rotation is actually a clockwise rotation. So let's type enemy1, and we can either change the angle directly, like so, or we can use a method called set angle. So that will rotate the enemy 45 degrees clockwise, and it's the same as doing. Let's do it with the method as well. It's the same as doing set angle and then 45. Oops. On the other hand, if you do minus 45, it means you are scaling to the other side, so counterclockwise. All right, so that is how you can rotate by picking the angles option. You can also use radians. So enemy1.rotation, we can change the value directly, like so. 45 degrees is pi divided by 4. So that is math.pi divided by 4. Will achieve exactly the same result as the 45 degrees. And we have that option as well to use the set rotation method. So in this case, we would be passing the radians in as a parameter, and that will give us the rotation. Now you see that we are rotating about the origin, which is in the middle. Let me just show you really quickly what happens if you change the position of the origin and you do your rotation. So let's do enemy1 dot set origin. Let's set it to the top left corner, so 0, 0, and you will see that we are now rotating about that point, which stays on the same position. But so we're not rotating about the middle anymore. We're rotating about that point that we've specified as the origin. So I'm gonna keep that, and actually I'm gonna comment that out because I like this approach better. So that is how you can rotate sprites. You now know basically how to do all the basic transforms of sprites. You know how to change their position. You know how to scale them up and down. You know how to flip them, and you know how to rotate them. And the next thing that I wanted to cover in this lesson had to do with the update method. So if you recall, we saw previously that scenes have different special methods, and there are more methods than this, by the way. This is not the full list. So one of them is update, and we know that we are preloading things. Then we call this create method just once, where we create our sprites, and then update, it's called 60 times per second if that is supported by your device. Older devices might not be able to achieve 60 frames per second. 60 frames per second is the frame rate that the framework aims to have, which is a good framework for a 2D game. So you want to achieve that, and you will most likely achieve that in a modern device, but in older devices it could be less than 60 times per second. So let's go and create our update method so I can show you the sort of things we can do in there. So let's type, this is called up to 60 times per second. And our scene was called game scene. So we got game scene.update, and we'll create our method here, our function. All right, so in here we have access to all of these sprites that we've been creating, and I'm gonna grab, but we actually don't have access to these variables because they were declared in the context of this function. So if we want to access those sprites in here, we need to change how they have been declared. I'll do that for the enemy. For enemy 1, we need to instead declare them as these dots, so that they are placed in the game scene and we can access them here. So I'm going to change this to this.enemy1, and I'm going to change the other occurrences of this variable just so that it's not confusing, or so that we don't run into errors if you decide to uncomment that to see what it does. And this is executed 60 times per second, so everything that we add here will be called with that frequency. So let's say that we want to increase the X position by a small number. Let's see what that does. So you can see that it's moving really slowly. We could definitely try a bigger value to make it more clear. And there we go. So we are moving that sprite, and it's of course gonna just go off the screen and keep on moving forever. By using the same approach, or let's skip that and comment it out. By using that same approach, we could also change the rotation of the enemy. So we could increase it by 1 degree, and that is then moving. So we can change all of these different things that we have seen, and you can obviously add more custom logic. So you can have if statements and a lot of other things, the things that we will cover later in the course. So now I have a challenge for you, which has to do with playing with update and with different things that we've been learning so far. Okay, challenge time. Make a sprite grow over time, only until it reaches twice its original dimensions. So once the width and the height have doubled, basically, you will make the growth stop. So pause the video, try to solve the challenge, and then join us for the solution. All right, welcome back. Let's solve the challenge. So I'm gonna do this with the player character that I have there. So I need to first place my player in the scene's context so that we can access it from different methods. So I've replaced that let by this dot, and I make sure that I replace all of these occurrences. And in here we're going to solve our challenge. So we're going to make the player grow. Let's make it grow first. So player.scale x. I'm going to increase this by a small number, something like that. And the same thing with the y. And when it comes to numbers, what I do is just throw numbers, and then I see if it's too fast, then you reduce the number. If it's too slow, you can increase it. So let's see what happens here. Yeah, it's growing, but it's growing without any control. So we need to set that limit for our growth. So we are going to check if we've reached the scale of 2, basically. So if this dot player dot scale, we're just gonna compare scale x, assuming that we are modifying both in the same way. So if this while this is less than 2, actually, while it is less than 2, we are increasing its size. But once it reaches 2, we're no longer going to keep on increasing its size. So as you can see, the sprite has grown until it reached a limit, and then it stopped growing. So we've covered quite a lot of ground here. You now know all of the basic operations, and now you know the basics of this update method, which is extremely useful when developing games with Phaser.